This video is on solutions. So a solution is a homogeneous mixture that forms when a substance dissolves in another substance. Solutions are made up of two parts. The first part is a solute. The solute are the particles that dissolve in a solution, whereas the solvent is the substance which the solute dissolves. The solvent can be called a dissolver, and our universal solvent is water. We can say that the solvent dissolves the solute. If we were to make a solution of salt water, here I would add into a beaker salt and water. When I do this, I first pour my water, and then after I pour my water, I would put in my granules of salt at the bottom. After I either stirred or heated my solution, I would notice that my salt particles would have disappeared or dissolved into my solution. And so then I would no longer be able to see my individual particles, but instead I would just see a solution that looks like water. Because I cannot see my individual particles, that means that it would be homogeneous. Here in my saltwater solution, I have my salt, which got dissolved by my water. My solvent dissolves the solute, so my water dissolved the salt. That means that water is my solvent, and my salt is my solute. I can have many different types of solutions. I can have a solution of solids. These would be called alloys. An example of an alloy is stainless steel. Stainless steel is made up of nickel, iron, and chromium. Liquids can be made into solutions. For example, in a lawnmower, you mix oil and gas. Those mixed together, you can't see the individual oil particles from the gas particles, and so we'd consider that a homogeneous solution. The air we breathe is also a homogeneous solution, because we have nitrogen, oxygen, carbon dioxide, and other gases all mixed together, and we can't see the individual gases. This is also a solution. Nitrogen is the most prevalent, so we would say that nitrogen is our solvent, and our other ones are our solutes. To make a solution, we can either dissolve or dissociate. Dissociation is a process in which an ionic or polar compound is separated into its ions. Here, water pulls apart the ions into solution. If I were to have a salt compound here, and salt makes crystals, here I have my sodium, which has a positive charge, and my chlorine that has a negative charge. These are considered ions because they have these charges. A water molecule comes along, and water is made up of hydrogens and oxygens. The hydrogens have a positive charge and the oxygen has a negative charge. And those positive charged parts to sodium is going to have an attraction for the negative charged part of water, so they're going to group up. And my positively charged part of my water is going to group up with the negatively charged part of my chlorine, and they're going to pull apart my salt into its separate ions. Dispersion is where water pulls apart a molecular compound. So this is a compound that does not form ions. Molecular could also be called covalent. An example of this is sugar water. Here I have sugar molecules and water molecules. My water molecules come in and attack my sugar molecules and pull them apart, so they get in between them. As my water molecules get in between my sugar molecules, they then dissolve the sugar until it mixes with the water and becomes a homogeneous solution. There's a common phrase called likes dissolves like. This means that compounds with similar polarities will dissolve each other. Polar and polar, and nonpolar and nonpolar. So polar and nonpolar have to do with how the electrons are arranged in a molecule. Nonpolar would be that there are symmetrical all over, and polar would be that there's more on one side than the other. If we go back up to our salt here, we have more electrons by the chlorine than by the sodium, thus the electrons concentration giving a negative charge over here and more of a positive charge over here. The most common polar solvent is water, and the most common nonpolar solvent that we'll use is oil. So when we're looking at making solutions, if I have a polar solute, I'll want to make a solution with water. If I have a nonpolar solute, I'll want to use oil as my solvent. When we're making a solution and we want it to happen quickly, we want to have many collisions between the solvent and the solute. The more collisions we can have, the faster my rate of dissolving. The first thing that we can do is have a large surface area, which means a small particle size. The smaller my particles, the small ones will dissolve faster than the large ones because there's more total surface area, and more surface area means more collisions. So if I have a chunk of salt, or if I had a sugar cube, and I were to stick that in water versus just lots of little pieces of sugar, or little granules, my granules are going to dissolve faster than my sugar cube. This is because all my granules spread out are going to occupy more surface area, right? These all spread out all over the place. This is all sugar from this one cube. I can spread out. Therefore, here we have more surface area. Here than we would here. I can also stir my solution. Stirring pushes and forces the solvent to crash into the solute, creating more collisions. And lastly, I can heat. As I heat, that increases the speed or movement of solvent particles, and therefore more collisions happen. Heat is movement, and so the more I heat something, the faster it's going to move.